where is this person that I've infected, and it ends up being really interesting twists to the problem of malware. And I've spoken at previous places mainly about anti-analysis, decompilation, and emulation. So why are you here and why do you care about what we're talking about? The deep dive, we really wanted to go and do this case study about Russian malware because you see lots of headlines out there and they're really misleading, or they're interesting because there's numbers and percentages, but percentages lie. If there's an increase of things, like just giving a percentage of saying like it increased 1,000%, what does that even mean? Does that mean you went from like 0 samples to having 10 samples or something like that? So we wanted to quantify and actually dig down and say like what is the difference? We're not just basing this off of total numbers of files that we see. Another thing is when you look at samples in the wild, AV companies usually distinguish samples by there's a hash. So when a unique file comes across the table, they say we have a new sample. But when you look into the code of those, sometimes there's absolutely no difference in the actual file. So if you're just going to go out there and grab 10,000 samples, but they do exactly the same thing, there's really no differences except for maybe a few modified flags. It kind of makes you, lets you boost up your number if you want to, but it doesn't really help you solve the problem at hand or actually understand the problem. And then another reason was we see a lot of things coming out of Russia and everyone just says it's Russian toll fraud and it's called fake installer, and they kind of just throw everything into it and it's like, well, it sends SMS, therefore it's the same thing. It's not true once you start digging into the actual technicality of it. So as I said, a new hash is not always a new sample. And this was an example I just pulled up from what we call alpha SMS. And I had 3 APK files, which is essentially a zip file. And you get the SHA-1 sum of those. The SHA-1 sum ends up being something different. So a lot of people at this point might say, I have 3 different samples and these are 3 different infections and now I have 3 things instead of 1. But once you start pulling these apart, you end up seeing the classes.dex, which is essentially where all that code lays for an Android application. They're all exactly the same. And Ryan will go into depth on this, but basically if I pull this open in a hex editor and I'm looking at a zip template, as you can see, the actual times of when these were packaged are different. And that's the only difference in here. There's also a configuration file for when the affiliates were going through. So different affiliates have different affiliate configurations, but the code is actually identical. So these samples are exactly identical. They just belong to different affiliates. So that's interesting in its own case, but you need to understand this difference instead of just saying I have 3 different pieces of malware here. The basic families that we went through were we ended up breaking up the Russian malware into alpha SMS, bad news, which is actually a recent one we just blogged about. This one was specifically interesting because it was basically around it was an ad SDK that these malware authors were attempting to get developers to use inside their applications. Then we also have connect SMS, deposit Mobi, fake browse, SMS actor. We also have at the bottom, this is not a toll fraud, but it is a Russian malware, not compatible, which I'll touch upon a little bit later. And as you can see, they all send SMS except for the bottom, but they do have other features sometimes in there, like downloading applications, trying to install those applications, or suggesting that a user install that application. A lot of them exfiltrate personally identifiable information, so that's stealing your contacts or attempting to look at your web browser history. And then it was also interesting to notice that some of these people were using obfuscation. It was all not off the shelf obfuscation. So it was all this custom made stuff that we're seeing, and you can actually see that between the different groups they started sharing obfuscation techniques. And we thought this was important because as you see, lots of people just say all those different families that have different feature sets, and they also have different ways of infecting people and different feature sets. Basically a lot of people just say, well, it's Russian SMS, who cares? Like let's just group it all into one. And you kind of miss the big picture of who's doing this and what they're actually attempting to go for. So as we were going through, just specifically I was looking at connect SMS, and I went through our archives of samples and I pulled a sample from A, F, P, and S. And so these are all different variants of the same family. And it ended up looking pretty interesting. You can see the package by date, when these were actually created by the malware author. And then the first instance actually just had no obfuscation in there. It was really simple. Basically you open up this application and it just sends an SMS and that's all. There's debug information in there, which ended up being kind of interesting because this means they didn't run ProGuard, they didn't run DexGuard, and they just had all this extra metadata sitting there in their application. Later on in F, we actually saw this is it was packaged a few months afterwards. They started adding more SMS endpoints. They actually extracted that into a configuration file. So it wasn't just sending hard-coded SMS, and it actually had all the SMS endpoints and the URLs started becoming encrypted in that external file. They also added contact exfiltration, which was interesting because they weren't actually spamming your contacts, but they're sending that off to a third-party server. So it was just an interesting way to see this sample evolve. Later down the road, we still see the SMS endpoints and the URLs encrypted, which was actually being used, the same cryptography was being used. They added more obfuscation at this time. So if you just looked at the two samples next to each other without digging down deep, you might say, this is brand new code. But you deobfuscate that, wait, they're using the same cryptography? Okay, they're even using the same keys. That ends up being an interesting correlation to draw. In the actual P sample, they removed the contact exfiltration. So it was interesting to see that these guys are attempting to evolve. Maybe they decided we're going to steal all of everyone's contacts. Maybe we're going to spam it. Maybe they tried that technique and it didn't actually work out, so they ended up removing it. Maybe they saw like a correlation of people are downloading less things because they added more permissions. And then in the last sample that we saw, and this one is actually pretty recent, they've actually moved the SMS and URL endpoints. They're still encrypted, but they're not actually kept inside the package. So what they're doing is they're actually contacting the URL and dynamically retrieving that information. So now you no longer have actual static configurations in the application. So another interesting point when we were going through that obfuscation, and here's a little example. This is actually from Alpha SMS. These people were building custom obfuscation tools. And essentially, if you know what Java code looks like, this is Smalley, which is a reverse engineered, basically taking the Dalvik bytecode and putting it into human readable format. This is basically a Java reflection call, and they're decrypting the string, which just looks like garbage essentially. And then they're using that decrypted string to reflectively instantiate some function methods. So I believe this was actually the start of a send message function. And it ends up being really interesting because when they're running these tools against all their samples, almost weekly they were changing their obfuscation methods. The patterns were essentially the same, but you couldn't actually look for the same encrypted sequences or the same exact pattern. It was very similar, but once you start deobfuscating all these, the samples end up aligning again and you see that code similarity coming back out. A lot of people have looked at this and said that, oh, okay, it's polymorphism, they're just trying to change it all the time. It ends up not being as scary once you understand what's actually going on. But it is interesting to see that different organizations tend to start sharing this obfuscation technique, and you actually see them distributing malware that's using the same techniques but then different seeds into that actual obfuscation. One of the really interesting trends, we sat down with our data team and we were looking at detection data. And this is just a quick cross section of one specific family. This one I believe was Connect SMS. And this is a little old for the data, but it does illustrate the point that each different color is a specific variant that was getting pushed out. So essentially what we saw is that there was different package names getting pushed out every single week. And once you read through the noise, what was actually happening is these guys were essentially operating as like a startup with like an agile type of methodology. So as you can see, almost this ends up mapping out to be 7 days. So for 7 days they're going to be pushing the same exact piece of malware to thousands of devices, and they keep just trying to jam it down the throat using spam techniques or getting infected hosts to serve this up, like infected websites. And what happens is almost right on midnight in Russian standard time, which that's not actual standard time, but Russian time. So basically at midnight they switch over and they just stop pushing that old piece of malware and they start pushing a new one. So they're incrementally pushing updates. So this is basically Russian malware startup 101, which ends up being really interesting. So while we were going through this, we actually came across not compatible. This isn't actually SMS fraud, but it is another interesting way to see how this mobile malware in Russia specifically is being compartmentalized and actually commoditized. This was an interesting one essentially because if you look at the diagram at the bottom, they're infecting devices and essentially using people inside the US, people in different countries as proxies to hide their traffic. And you might think like, well who cares, like what are they actually using this for? It looked like what they were doing was they seemed to be buying up swaths of compromised accounts or compromised websites, luring victims in through there, actually getting the devices infected. And now once you have someone in the US, maybe they're starting to sell these services and actually let other people use that proxy connection. So what this looks like it's going to be doing, and we've actually observed traffic of them purchasing tickets online. So this most likely is to evade actual fraud detection systems. So that, when you see someone from Romania buying Justin Bieber tickets for LA, that probably triggers a flag and you're like, well, why is that, I mean, everyone loves Justin Bieber, but Romania, I don't know. Like, it's a pretty long flight. So they're actually going to go through and they're going to take a device that's infected in LA and then they're going to just proxy their traffic through there. They buy that ticket most likely with a stolen credit card. They then have a mule pick it up. Maybe they sell that. They do something with that ticket, but basically they're allowed to get around that fraud detection system because they look like they're actually an endpoint that is a viable endpoint for purchasing that type of work. And I'm going to hand it back over to Ryan, which please buy him some drinks too.
Thanks, Tim. So I'll step back for a second. So just to summarize, when we had this large amount, so these Russian SMS fraud organizations we noticed were accounting for 30% of our overall detections worldwide. So that's a huge number. And it's a huge number of samples of malware to look at. So when we look at classifying them and doing the deep analysis like Tim said, it's important to not just call them all, oh, this sends an SMS, so I'll call it SMS send. But really categorize it by individuals because they evolve differently. Different actors act differently. And once we started dividing them differently, we noticed certain particular actors evolving different than the others. And they appeared to be distributing at higher and higher rates. And so this led us to find these SMS fraud, basically cottage industries, where there's an entire industry built around SMS fraud. And the entire distribution channel has been commoditized where everybody's getting paid to do their little piece of the pie and they specialize in that specific thing, maybe distributing or creating fake websites with realistic looking skins or themes, or some people specializing in social media distribution through Twitter or Facebook or things like that. But each person specializing in one thing or another, and that has led to these top 10 organizations that we've identified accounting for over 30% of the overall detections. And that's quite significant. So this is DEF CON after all, so this is an investigation of Russian SMS fraud, but it could also be called, if you happen to find yourself in the Moscow International Transit area, saving up for a permanent vacation in a South American country, which we all know there's other outs, here's how you might find some extra cash. But please don't. I'm not advocating that. So you might go to a chat room like this. There's plenty of chat rooms, or forums rather, in Russia that are specialized in what they call black hat SEO or web monetization. Some more gray than others. There's lots of ways to monetize in Russia, as I'm sure you guys are well aware. And so this one, you might be searching for Android WAP. WAP is the wireless application protocol, and that's basically what Russians call the data channel over a cellular network. So anything that has to deal with mobile data, they call WAP. So these systems are typically called WAP click or WAP this, WAP that. So you find one and it says that it has unique landing pages and it's the best of the best. So you click on that and it tells you a few things. It tells you they pay out every Thursday. It says that they will help you. They have the best successful landing pages. They'll help you distribute. And essentially what this is this is an advertisement for an affiliate system where you can sign up, and if you have mobile traffic, you can sign up and they will help you distribute these Android malware that they'll custom package for you and deliver to your victims transparent to you. So you just set up websites, you drive traffic, you get money. And to see how easy that is, I don't know if this video will play, but yeah, so they make it seem like child's play. Like you sitting out on the beach, riding on top of mobile phones, coins dropping out of the sky. You have to do a little work, but we'll take care of the rest. And that's essentially what these organizations are. They take care of the technical parts, they take care of the campaign running and things like that, and you just have to deal with building out websites and making money. So we have a life cycle. I'll go around it piece by piece. So individually I'll talk about the HQ organizations is what we're calling them, but they're basically these affiliate marketing headquarters. These are the guys